Welcome! In this video, we'll explore the world of binary code, often called the language of computers. Binary is the backbone of digital computing, used in both software and hardware design. There are two main types of binary codes, weighted and non-weighted. Understanding binary is essential if you're interested in computing, electronics, or coding, because it forms the basis for how information is stored and processed. What is binary code? It's a way of representing information using only two states, 0 and 1. Each binary digit, called a bit, is the smallest unit of information in computing. Binary operates in base 2, unlike the decimal system we use, which is base 10. This base 2 structure is perfect for representing the electrical circuits in digital devices, where just two states, on and off, high and low, or true and false, are needed to carry information. There are two main categories of binary codes. First, weighted codes, where each bit has a specific assigned weight, just like in our decimal system. Second, non-weighted codes, which don't use the standard positional weights found in traditional number systems. Examples you might encounter include BCD, 2421, and 5211 codes for weighted, and XS3 and gray code for non-weighted. Each serves a unique role in different digital applications. Let's look at weighted binary codes in more detail. The most common is the 8421 code, also referred to as binary coded decimal or BCD. Here, each decimal digit is represented by a 4-bit binary number. The weights are 8, 4, 2, and 1 for each bit, just like the name suggests. Another example is the 2421 code, where the weights for the 4 bits are 2, 4, 2, and 1. There's also the 5211 code, which uses weights of 5, 2, 1, and 1. These weighted codes are important in digital devices for reducing errors and ensuring an accurate representation of numbers. Now, let's explore non-weighted binary codes. The XS3 code, for instance, takes each decimal digit, adds 3, and then represents the result in 4-bit binary. Gray code is another well-known non-weighted code, where only one bit changes between successive numbers. This feature makes gray code particularly useful in applications like analog-to-digital converters, where it's important to minimize errors or glitches as values change. Next, let's talk about reflective and sequential codes. Reflective codes are ones where the highest value in the code set is the binary complement of the lowest value. Examples include 2421, 5211, and XS3 codes. On the other hand, sequential codes are structured so that only one bit changes at each step. Gray code is a perfect example. This single-bit difference helps reduce glitches and errors in hardware, making sequential codes highly useful in digital systems. Binary isn't just for complex electronics, it's all around us in everyday life. Barcodes and QR codes use binary patterns for identification and data storage. Computer memory addresses and instructions are written in binary. Even when you stream audio or video, the files are converted into digital bit streams, binary at work. Nearly every modern device you use relies on binary for its operation. Wondering how to convert decimal numbers into binary? Here's how it works. You divide the decimal number by 2 and write down the remainder, either a 0 or a 1. Keep repeating this process, dividing by 2 each time and recording the new remainder, until the result is 0. The binary representation is the list of remainders, read from bottom to top. For example, if you convert the decimal number 25 using this process, you end up with 11001 in binary. Binary also plays a major role in digital communication and security. For error detection, techniques like parity checks and Hamming codes can spot bit errors and often correct them. In encryption, data is encoded in binary to keep it secure. Digital forensics uses binary hashes to verify file authenticity and track changes, ensuring data hasn't been tampered with. Here are some frequently asked questions about binary. What's the main purpose? Binary translates digital information into a universal format that computers understand. Why are there multiple binary codes? Each is optimized for different tasks, some for error checking, some for faster computation, and some to prevent glitches. How can you practice? Start by converting simple numbers and texts into binary using online tools or by hand. Are other codes used besides binary? Yes, hexadecimal, which uses base 16, and octal, which uses base 8, are also common. And in real life, binary is everywhere, from streaming music to scanning groceries at a store. To wrap things up, binary truly is the fundamental language of all computers. Both weighted and non-weighted binary codes exist to meet the different needs of devices and applications. From storage to communication, multimedia, and security, binary makes it all possible. By understanding how binary works, you'll gain key insights into the world of computer science and digital technology.